everyone, how are you my dear children? Hope you all are safe and fine. Today we are going to discuss electric field intensity due to continuous charge distribution. In last video, we have discussed what is this continuous charge distribution. Okay, so we know what is the electric field intensity for point charge. We know electric field intensity for point charge is E is equal to 1 by 4 pi epsilon naught Q by R square. This is for your point charge. This formula is for point charge. Now we'll see for the continuous charge distribution. So we'll now find out electric field intensity due to, in first case, linear charge distribution. Let me clear this. So we'll first see due to electric field, we'll find out E due to linear charge distribution. Let the curve is like this. This is your line, okay, linear charge, and over the line, or you can say, you can take rod also. Now here continuously charge is distributed, and we want to find out the electric field over here, which is at a distance r like this. Then how to find out? Children? Now see, we'll consider a small element of this linear charge distribution of this line, and let this element length is dl. Okay, and this element dl now consists the charge dq, very small charge. Okay, since we are considering the small elemental length, consider this is your small element length, elemental length, and which consists the small charge dq. Since it is very small, we can treat this dq charge as point charge. That means your dq charge behaves as point charge. Since it is very small, behaves as point charge. So we can treat it as a point charge. Okay. Now your electric field will be in this direction, dE, due to this elemental charge dq. Okay, children. Now dE is equal to how much? 1 by 4 pi epsilon naught dq by r square. This is your electric field due to dq charge. Now for the entire length, what we have to do? We have to integrate over the length L. So what we know, your linear charge density lambda is equal to dq by dl. So over the length, that means we have to replace this dq in terms of dl. Then only we can integrate. We know normal mathematics rule. Okay. So what we'll do, we'll write now this length L 1 by 4 pi epsilon naught lambda dl by r square. Okay, children. Now your electric field E will be how much? Electric field E will be how much? E is equal to 1 by 4 pi epsilon naught over the length L. We'll take the integration lambda dl by r square. Clear? So this is the electric field then intensity. This is length L. Electric field intensity due to linear charge distribution. Okay. Now we'll see what is the electric field intensity due to surface charge distribution. We have to find out E, electric field intensity E due to surface charge distribution. Then how to find out? See, we'll consider a surface like this, and over the surface these charges are distributed continuously. Then we have to find out the electric field intensity at this point. Suppose this is your point P. Then what we have to do? We have to consider a small element. Okay? A small element S over here. Okay? Or you can say ds. We'll take a small element ds. And it contains charge. We'll consider now. This is the distance. Okay? You can say R. So, we'll consider, let us consider the small elemental area ds, okay, having dq charge dq. Okay, since it is a very small charge, we can treat it as a point charge. Okay, now the electric field due to this dq will be how much? It will be d like this. Okay, now your dE will be how much? It will be 1 by 4 pi epsilon naught dq by r square. We know surface charge density sigma is equal to how much? dq by ds. So that means dq is equal to sigma ds. So here we can put it like this. This is equal to 1 by 4 pi epsilon naught. Okay, dq means, before putting that, no, we can put, why to put? No, first see this much of electric field we got now due to this point charge, but we want for the entire surface. So like how we have done for the linear charge distribution, same we'll take the integration, but here now integration over the surface S will take. Okay, so now tell me what to do. So dE will be E, integration of dE will be E. Now we'll write integration of S 1 by 4 pi epsilon naught dq will put sigma ds by r square. Okay children, so your final expression will be E is equal to 1 by 4 pi epsilon naught, since it is constant, we'll take it out from the integration, sigma ds by r square. So this is your electric field intensity due to surface charge distribution, children. Okay, now last one we'll see electric field distribution, electric field intensity due to volume charge distribution. So electric field intensity due to volume charge distribution. Okay, that means your charge is distributed over the volume. So your charge is distributed over the volume like this. This is a volumetric. So charge is distributed over the volume now. Okay, so how to find out that? We have to again take a small elemental area like this. So this is not area, small elemental volume we have to take. Okay, let that volume is dV. So dq charge is present in the small elemental volume dV. Since it is a very small charge, so we will treat this dq charge as point charge, children. Okay, now we can write the small elementary. Suppose we want to find out over here r distance. So we have to find out the electric field at this point. So your electric field intensity will be dE will be in this region. Okay children. So what is your dE now? So dE will be the small electric field intensity due to small charge dq. So we'll write dE is equal to 1 by 4 pi epsilon naught dq by r square. Okay, clear? Now what we have to do? We know your volume charge density. We know that volume charge density rho is equal to dq by dv. So that means dq is equal to rho dv. So for the entire volume, we have to take the integration like this over the volume. Okay children. So what we'll write? So we'll write dE and we'll write over here 1 by 4 pi epsilon naught rho dV by r square children. Okay. So what we'll write? We'll write dE is E. So E is equal to, we'll take out this 1 by 4 pi epsilon 0, that is your constant. So out of the integration, now V, so rho dV by r square children. Is it clear children? So this is your electric field intensity due to volume charge distribution. Hope this video lecture is clear to you. Okay children, if anything, please let me know. Leave a comment in comment section box. If you like these videos, please like this video and try to subscribe also. So it will encourage me. Okay children, take care. Thank you for watching.